In this video, we're going to take a look at how to calculate standard deviation by hand for a small data set. In practice, you'll be able to calculate standard deviation with a calculator. So the first thing we need to do, standard deviation means standard deviation from the mean. So we need to find the mean of the data. And we add this up, we get 40, 10 plus 7 plus 5 plus 8 plus 10. And there are 5 values, so our mean, of course, is 8. And the idea of standard deviation is basically like, on average, I want to try to identify how far away the data is from 8. And so to do this, it's kind of a process, which is why we generally don't do it by hand. We use technology, but we can, let's create a table. We're going to list all the data values, represented with x sub I, and I'm going to list them vertically. So 10, 7, 5, 8, and 10. And then the deviation is actually the difference between each value and the mean. So each data value has a deviation. We find it by subtracting the mean. So 10 minus 8 is 2. 7 minus 8 is negative 1, 5 minus 8 is negative 3, 8 minus 8 is 0, and 10 minus 8 is 2 again. If we tried to average the actual deviation values, we'd always get 0. They always add up to 0. So we have to do something else. And the something else that we do is we square the deviations. So in one more column, I'm going to square each of these values, and in symbols, that's going to be x sub I minus x bar squared. So 2 squared is 4, negative 1 squared is 1, negative 3 squared is 9, 0 squared is 0, and 2 squared is 4 again. And these values, since they're all non-negative, these values we can add together. We get 18, and we can kind of take the average. And so what I'm showing you is how to find the population standard deviation. There's a slightly different thing called the sample standard deviation. But for the population standard deviation, we just take that 18, and we divide by the number of numbers. We get 5. So 3.6 is the result, and this has a special name. It's called the variance. It's not quite the standard deviation, it's the standard deviation squared. So we use sigma represents the standard deviation, the population standard deviation, and so this is called the population variance. It's sigma squared is its symbol, and let me write that word here, variance. And to find the population standard deviation, we just have to take the square root of that result. So the square root of 3.6 is roughly 1.897 if you work it out on a calculator, and digits beyond that. And this is equal to sigma. This is equal to the standard deviation. So to 3 significant figures, we could say 1.90. So again, in general, we can use technology to find the standard deviation if we ever need to do that in a data set of any size. But conceptually, to understand where this number comes from, it's good to maybe do it by hand once or twice. So 1.9, if you look at this set of values that we found, the different deviations, 1.9 is kind of roughly in the middle, right? If you ignore the negative signs, some things are as far as 3 below the mean, some things are as far as 2 above the mean, and 1.9 is sort of on average a representative value, right? Because negative 1 and 0 are less than that from the mean, and the other 3 values are more. So what I encourage you to do to practice this and think about standard deviation is, with the following data set, try to find the standard deviation. So slightly bigger one, just 6 values this time: 4, 12, 14, 11, 1, and 6. Try to create a similar table and find the standard deviation for this data set. All right, thanks for watching. I hope you enjoyed the video.